All right, so we're going to graph another exponential, and maybe you want to give this a try without looking at these values, but this time it's going to be 1/3 to the x power. Just want to show you the difference, what happens when the base, okay, so our book uses this. They show that the exponential, they call it a to the x. A can be anything. And so if a is greater than 1, we got an increasing graph. And then what happens if a is less than 1 and bigger than 0? And our book also makes the statement, and this will be clear in the next section when we come back, why this is true, but a will never be 1 because 1 to anything is just 1. It's very boring. It's just a line. And then a will not be negative because we're not going to consider negatives to exponents. It's a lot of fun, but it is something for some analysis class later in your math lives if that's where life takes you. So we're only going to consider values of a either bigger than 1. We get an increasing graph. Value of a between 0 and 1. We're going to talk about what that's going to be when we graph it. And here are our values. So 1/3 to the x. When I put in 2, 1/3 to the second, 1/3 times 1/3 is 1/9. 1/3 to the first power is just 1/3. 1/3 to the 0 power, again, don't say 0. Anything to the 0 power is 1. 1/3 to the -1, negative exponents, flip your base. So this becomes 3, or 3 to the first. And then 1/3 to the -2, when I flip the base, it becomes 3 to the second, or 9. So when I graph this, so when I start with 2, when I went over 2, my value was 1/9, so something real small. When I had 1, it was 1/3, so a little bit bigger. 0 was 1. -1 gave me a y value of 3, and -2 gave me a y value of 6, 7, 8, 9. So notice this graph has the same domain and range as before. I'm not going to rewrite those, but notice when I trace this along, I get something that's decreasing. So we're going to go back over to this board, lovely assistant. So when a is greater than 1, I had something that was increasing. When a is greater than 0 and less than 1, I get a function that is decreasing. That would be if you were in a science class, you were talking about radiation. This is what's called, back over here, sorry, I don't mean to make everybody dizzy. This is what's called exponential decay, or it's a decreasing function. We're going to do one more quick thing. We've already done a couple of transformations when with the a is greater than 0. So we're just going to do this last problem. Pause the video. Make sure that you can recognize this yourself. If this is 1/3 to the x, I want to know what 1/3 to the x and then -4 would be. So again, my -4 is outside the graph. It's not part of the exponent, so that means I'm going to take all my y values down 4. So I'm going to start with that horizontal asymptote, 1, 2, 3, 4. Let's see if I can do this well. It's always debatable. Oh, that's not too bad for a Thursday. And now I'm going to take all of those y values and drop them down 4. So this y value that's at 1/9 is going to drop down. It's going to be just above the asymptote. This one that's 1/3, same thing. This one that is at 1 is going to be -3. This one that's at 3 is going to be -1. And then this one that's up at 9 is going to be 8, 7, 6, and it's going to be 1, 2, 3, 4, 5. There, I lost count, but I got it back. And so my graph was just translated down 4 units. There you go. There's your exponential graphs.